Good morning. Thank you very much for inviting me to the DAPS conference. It's been a pleasure to be here. My name is Arnold Jacobson. I'm a professor at the University of Toronto, and I gave the keynote this morning on the renaissance of Byzantine fault tolerance. The problems that we're trying to address are central to any distributed ledger, any blockchain, any decentralized application. All these systems require consensus, and all these systems have to work out in the wild under Byzantine conditions, meaning under arbitrary failure conditions. They're constantly being attacked, and how to protect the digital assets in these type of systems, that is key. And that's the research that we have been doing for a number of years, and today I had the pleasure of presenting some of that research. Our first core idea is Prestige BFT. There's a paper if you want, it's online. And in Prestige BFT, what we do is we introduce an active view change mechanism to Byzantine fault-tolerant consensus protocols. That mechanism is based on assessing a reputation for each validator, for each node that partakes in consensus. And that reputation score determines the likelihood of a node being chosen as a future leader to orchestrate the protocol. And it is based on whether that node has been responsive in the past, has been replicating transactions in the past, has an up-to-date replication log, and how many times it tried to attain leadership. All that information is meshed together in what we call a reputation score. In turn, that reputation score then turns into a penalty, and nodes have to redeem themselves in order to attain leadership. I spare you some of the details here, but this is very unique work that showcases how active view change can be implemented for Byzantine fault tolerance. And secondly, I introduced a project called vGuard. Similarly, there's code available online, and there's a paper online, and it tries to cater towards use cases that have a very high churn in node membership. Nodes that are trying to see consensus are coming and going. So where does this play a role? Well, this plays a role in vehicular automation, in vehicles that drive about the city, drive about highways, and are trying to replicate core information about their operational status, as opposed to locking that data into a manufacturer's cloud infrastructure where you may or may not have access to it. Our idea is to bring it into a blockchain and retain it. Here we're catering towards use cases that get by with replicating a few kilobytes. That's sort of our current operating point for that work. Thank you very much.